Hello students, welcome back to the third video of this playlist. So in this video, we will be solving the third question from M1 January 2024 paper. So let's see what's the question number 3 from M1 January 2024 paper is about. So basically the concepts behind this question number 3, it's from the very first question of your M1 book, very first chapter. First chapter is modeling assumptions, so not from that chapter. Basically the next chapter, there is chapter number 2, which is projectile motion. Okay, so the concepts behind this question is from chapter number 2 of your M1 textbook, and also in the part C, or that is the last part of this question, you should have idea about dynamics, okay, which is discussed in chapter number 4 of your M1 textbook. So definitely you should have idea about the concepts that has been discussed in chapter 2 and chapter 4 of your M1 textbook. So let's get started with question number 3. A van travels with constant acceleration. The acceleration is constant, keep in mind, along a straight horizontal road. It is moving in a straight horizontal road. Okay, fine. The van passes a point A with speed u meter per second, and 20 seconds later passes a point B. Okay, so the time difference between the passing 2 points, it's what? 20 seconds. Okay, the distance AB. Okay, point B with speed. Okay, speed is also given at point B. What was the speed of the van? The distance AB is also given. The distance between the 2 points A and B, it is 400 meter. So this is basically the introduction to this question. Now, in part A, they are asking to show that the initial velocity, right? The speed, we need to find out the initial velocity. U, it is what? 12. It is not velocity, it is speed. Okay, we need to find out that u is, we need to show that u is 12. Okay, so let's consider, like, just figure out what are the quantities given in the question. We need to find out u. Fine, the time is given, we know the time, right? And what else we know? We know the final velocity, right? And what else we know? We know the distance, right? So we know from the concept of physics and Subot equations, not physics, yeah, physics, stuff from physics definitely. So from the concepts of Subot equation, we know that if we know 3 of the quantities, then we can easily find out the other 2 quantities of motion, right? So since we know the 3 quantities S, V and T, so we can easily find out the value for U. So let's go for that. So which formula we should go for? We know S, we know V, we know T. We need to find out U. So straightforward, we will go for this formula. Like, we should consider a formula that will have S, V, T and U. Okay. So S equals to U plus V over 2 times T. We got U there, we got V there, we got T there, we got S there. Isn't it? Okay. So S equals to U plus V over 2 times T. So we will use this formula. So what we know, U plus V, initial velocity is how much? U plus V is 28 over 2 times T. T is how much? T is given as 20 seconds. This is equals to how much? 400 meter, right? Okay. So 20 over 2, that is 10. So U plus 28, this is equals to how much? 400 over 10, that is 40. Okay, so U equals to how much? 12. So U equals to what? 12. It has been shown, right? That's it. That's what they have asked in part A. Next is part B. In part B, they are asking to find the time taken for the van to travel from A to the midpoint of AB. We need to find out the time taken for the van to travel from A to the midpoint of AB. So midpoint of AB is how much? Definitely S would be how much? 200, right? So s is 200 meter. We know that initial velocity is what, 12 meter per second, right? We need to find out the value for time, right? T has to be found. And what else we know? We know nothing other than that, right? So we know s, we know u, we need to find out t. T should be found. So we need to find out from the given data in the question, we should figure out the next quantity. Next quantity is what? Acceleration. We know s, u, v, t. Remaining is what? A only. So let's figure out a. So use this concept. Initial velocity is known, final velocity is known, time is known. So we can easily find out the acceleration, right? So what? Acceleration a is equals to how much? V minus u over t. V is how much? 28 minus 12 over the time is how much seconds? 20 seconds. So you will get the acceleration, there is 16 over 20, there is 4 over 5 meter per second squared. Okay, so this is the acceleration. We got the acceleration. Okay, so we know another quantity now, right? So now we can figure out the value for the time that is required for the van to reach the midpoint of the what? Point AB. Okay, so which formula should we go for? We know u, we know s, we know a. So we have to go for s equals to ut plus half of what? At squared. Okay, exactly. So s is how much? Do we know the value for s? That is 200, right? So 200 equals to initial velocity is 12t plus half of at squared. So half times 4 over 5, that would give you 2 over 5 t squared, right? Okay, now take 200 to the right hand side. So what you will get 2 over 5 t squared, and then what was there? 2 over 5 t squared plus 12t minus 200, that would be equals to 0. Now multiply both sides by 5. So 2t squared plus 60t minus 1000, this is equals to what? 0. So divide both sides by 2, you will get t squared plus 30t minus 500, that would be equals to 0. Fine. Now we need to find out the value for t. Is there any possibility for using middle term factorization? 40 times 10, that is 400. 50 times 10, that is 500. But okay, it's not possible. So let's go for quadratic formula. Negative 30 plus minus square root of b squared minus 4ac, right? So b squared is 30 squared is 900 minus 4 times negative 500. A is 1, so that is plus 2000. That is square root of 2900 over twice of a, that is 2. So we need the value for t. So t would be, consider the positive value. So this is square root of 2900, that is 10 square root of 29. So 10 over 2 is what? 10 over 2, that is 5 square root of 29. Okay, minus what? 15. Okay, so let's write it to 3 significant figures. So what you will get, 10 square root of 29 minus 30 over 2, this is basically 11.9 seconds. 11.9 seconds. Okay, this is up to 3 significant figures. That's the value for t. That's the time required for the van to reach the midpoint of AB. That's what they have asked for in part B. Fine. Okay, next is part C. What they have asked in part C, the van has mass 1200 kg. Fine. During its motion, the van experiences a constant resistive force of magnitude 260 Newton. Resistive force, constant resistive force. Okay, that means it is resisting the motion of the van. So part C asks to find the magnitude of the driving force exerted by the engine of the van as it travels from A to what? B. So let's consider this scenario. The van is moving, consider it is moving to the right, to this direction, and it has a driving force D, and opposing force is what? 260 Newton, right? And its mass is given 1200 kg. So we need to find out the resistive force, the driving force. So do we know the acceleration? Yeah, we know. The acceleration is how much? Just we found in part B, that is 4/5. The acceleration is in this direction, it is 4/5 meter per second squared. So we need to find out the driving force. Okay. So for finding the driving force, what we will consider? Resultant force. Okay. Since it is in what? Motion, it is accelerating. So that means there is a resultant force acting on the body. So resultant force equals to what? M times the acceleration. So resultant force is the vector sum of all the forces acting on the van, right? So that would be what? For part C, resultant force equals to what? MA. Resultant force equals to MA. So resultant force is vector sum of all the forces. So consider the driving force is D minus the resistive force is 260 Newton. This is equals to what? Mass is 1200 kg times the, acceleration is 4/5. Fine. Pretty easy. Now find out the value for D. So 1200 times 4/5. So that is 240 times 4, 960 plus 260. That would give you 1220 Newton. Okay. The driving force is 1220 Newton. And that's what the question has asked for. The driving force of the van. And that's all about question number 3 from January 2024 Mechanics 1 paper. That's it.